Hi, I'm Jack Stromatt. I'm in the Experimental Cancer Pharmacology Laboratory. I'm a third year, and I recently received second place in the College of Pharmacy 3-minute talk thesis. My research primarily focuses on acute myeloid leukemia, drug resistance within AML, and some of the modulating factors of pharmacokinetics. Have you ever noticed that drugs might affect people differently? For instance, you might drink 5 cups of coffee in the morning and feel completely fine, whereas somebody else will have 1 cup and will bounce around all morning. Well, there might be multiple reasons for this. For instance, you've been drinking coffee for the last 10 years and you've built up tolerance. Or maybe you are a fast metabolizer and your genetics allow you to break down caffeine faster. Another idea that I've been studying is the idea that differing disease states can affect your ability to absorb and eliminate drugs. So what's the big idea? Just drink more or less coffee depending on your situation. Well, in the situation where patients are in critical conditions and getting the dose right the first time is very important, it's a lot more serious of an issue. So for instance, if we look at cancer patients, we've noticed that cancer patients have much higher variability in the way that they absorb and eliminate drugs. And with these cancer patients, it's critical to give them the proper dose, because if you give them too low of a dose, then the treatment will fail. And if you give too high of a dose, these patients will suffer serious side effects, which can lead to reduced quality of life or dose interruptions, which can also lead to treatment failure. So how and why does this happen specifically to cancer patients? So to study this, we've looked at healthy tissue and we've compared this to tissue burdened with cancer. And we've compared the tissue as cancer progresses. And what we've noticed is that as cancer gets worse, the protein content of their liver is changing over time. And we believe that this is causing the issue with their absorption and elimination. So why does that happen? Well, what we've also noticed is that cancer often induces inflammation. So we call this cancer-induced inflammation. And we know that inflammation by itself can modulate your ability to absorb and eliminate drugs. So it makes sense that cancer patients, cancer-induced inflammation, can also do the same and affect your absorption and elimination. So the next steps, and what we're focusing on now, is identifying exactly where and how this happens in cancer patients. So there's a lot of ways that the inflammation can be different in these patients. So what we need to do is find the key regulators from cancer-induced inflammation and find out how they're related to the liver and its ability to eliminate drugs from our body. So if we can understand this, then we can better dose these patients to make sure that they are receiving a potion and not a poison.